Imagine you are deciding how to spend your lunch money. You can buy a different combinations of two things: slice of pizza and a can of soda. Let us say four slices of pizza and one soda makes you perfectly happy. But what if you only get two slices of pizza? To keep you just as happy as before, you need more soda. Let us say three cans. Because both combinations give you the exact same total satisfaction. You don't care which one you get. You are completely indifferent. In microeconomics, this simple choice helps us unlock three major exam topics: the indifference sets, the indifference curves, and indifference maps. In this video, we will break down all three steps by step using our pizzas and a soda example. Welcome to Belay Economics. Let us start with the raw data. Indifference set or indifference schedule is a combination of goods for which the consumer is indifferent, or the consumer is faced to dilemmas. It shows the various combination of goods from which the consumer derives the same level of satisfaction. Consider a consumer who consumes two goods, X and Y. In the table below, each combination of good X and Y gives the consumer equal level of total utility. So, individual is indifferent whether he consumes combination of A, B, C, or D. That is how indifference schedule or difference set shows. The combination of both gives the same satisfaction. So you are indifferent or you face dilemma to choose which one is best. Let us take the practical example, how things are indifferent. For example, if someone asks you to choose your father or your mother, which one is best for you, or which party you select, father or mother? It is different to identify which one is good for you. Both are the same. At this time, you are indifferent to choice. With the same style on commodity that gives the same satisfaction, you face the choice which one you are going to choose or which one you are going to consume, since the satisfaction they give is the same. Such is called indifference. A curve that shows such point is known as indifference sets or indifference curves or indifference schedules. Indifferent curves. When the indifference sets or indifference schedule is expressed graphically, when it explains graphically, it is called as indifference curves. When it has explained by using of the table, we can say that is indifference set or indifference schedule. When we use a curve or graph, we call it indifference curves. An indifferent curve shows the different combination of two goods which yield the same utility or the same satisfaction or levels of the satisfaction to the consumer. A set of indifference curve is called indifference maps. So we have seen the indifference set or schedule, or we can call it table. And also we have seen indifference curve, which is shown by using graph. And the set of this indifference curve is called as indifference maps, or the set of indifference curve on the graph is called as indifference map. Look, indifference curves and indifference maps. The first one is indifference curves that gives the same satisfaction at the points, and the collection of this indifference curve is known as indifference maps, which is found on the next one, on the second. You can see from our table, number one, indifference curves. Number two, the collection of these curves called together as indifference map. The property of indifference curves. Indifference curves have negative slope or downward slope. As you see from this graph, it is downward growth. Indifference curve negatively sloped because of consumption level of one commodity can be increased only by reducing the consumption level of the other commodity to make it the same value or the same combination. You have to sacrifice one to get another by the same amount, even though it is not perfectly substituted. In other words, in order to keep the utility of the consumer constant, as the quantity of one commodity is increased, the quantity of other must be decreased. This is how you can forego the other to get the best alternative. This is why it becomes negatively sloped or downward slope. The other property of indifferent curve is indifferent curves are convex to the origin. It is not concave, rather it is V-like curves to the origin. This implies that the slope of an indifferent curve decreases in absolute terms as we move along the curve from left downward to the right. The convexity of indifference curve is the reflection of diminishing marginal rate of substitution. When you go down, the marginal rate of substitution is diminishing. So, assumptions imply that commodities can substitute one another at any point on indifference curves, but are not perfectly substitutes. The commodity you choose is not perfectly substitute. For example, if you substitute banana with orange, it is not the same as that of orange is not the same with that of banana, even though it is substituted, because the value is not the same. Means it is not perfectly substituted, and because of that it is convex to the origin. The third property is higher indifference curve is always preferred to lower one. As you see from indifferent maps, the higher indifference curve is preferred by the consumer because it gives the highest satisfaction. The farther away from the origin indifferent curve lies, the higher the level of utility it donates. Because of that, the higher one is the best. Baskets of goods on higher indifference curves are preferred by the rational consumer because they contain more of the two commodities than the lower one. So as you go from left to right, the utilities more satisfaction is more increased. So you can choose the higher parts or the higher points. Number 4, the indifference curves never cross each other or cannot intersect. This is another property of indifference curves. The assumptions of consistency in the transitivity will rule out the intersections of indifference curves. The following graph shows the violation of the assumption of preference due to the intersection of indifference curves. What the following curve shows. Let us see. Look how indifference curve 1 and 2 cross each other. This is a violation of the property of indifference curves. What happens then? The above figure, the consumer preferred bundle of B to bundle C. This is what we have seen before. The highest indifferent curve is preferred. Because of this, the consumer preferred bundle B to bundle C because the C is down, the B is above the C, so it is preferred areas on point. On the other hand, the following indifferent curve number 1, the consumer is indifferent between bundle A and C. And along indifference curve 2, the consumer is indifferent between bundle A and B. According to the principle of transitivities, this implies that the consumer is indifferent between bundle B and C, which is contradictory or inconsistent with initial statement where the consumer prefers bundle B to C, or the higher indifferent curve is preferred by consumers. But because of this intersection point, because of they are intersected, the assumptions or the property is violated here. Therefore, indifference curve never cross each other. If that is crossed, what we have discussed before, or the property of indifferent curve is violated, and you are going to face for to choose which one is best for you. You are indifferent between B and the C. But as principle, B is more than C. But because of it crossed each other, now the consumer is indifferent to choose B to C. So it is not cross each other according to the property. If crossed, such problem is happens. Thank you for watching. Thank you for being part of today's session, and I hope you found it helpful and informative. If you enjoyed the lesson, don't forget to subscribe, share, and like my channel. In the next, we will explore a marginal rate of substitution. We will see what is marginal rate of substitution and how it happens in realities in our daily life. We will apply it.